Hi, my name is Purna Mokhtan, and today I'm going to present Interactive Advanced Concept Presentation 8. The topic name is Kinetic Sand. Okay, first of all, I would like to introduce about monomers, polymers, and condensations polymerizations reactions, how it is occur. A molecule compound, either natural or synthetic, um, they are made up of many repeating unit called monomers, and they have properties that differ greatly from those of small ordinary molecules. Polymers tend to fall into three phases. First one is a hard and stiff glass-like solid, and second is a soft and flexible elastomeric rubber or viscous liquid depending on temperature. Uh, Polymer are often divided into two groups based on their informations. Like one is additional polymers and condensation polymers. In additional polymers, which are we can see here, this is the um, additional polymers. In here, the condensation additional polymers which are shown up here, and this is the um, additional polymers, and this one is the conventional polymers. In additional polymers are formed when monomer together, joined into end. This process can be initiated by a radical, which is shown here, this one, and it is a species that contains an unpaired electron. But in condensation polymerization, here this is mainly formed when molecules with a different functional group combined with the eliminations of a small molecule such as water. We can see the water, but it is behind my video. Polymer have endless application in the real world, such as synthetic fiber like nylon, which are used to make many materials, including clothing. And some few characteristics of the polymer: it has a low density, a low coefficient of friction, good corrosion resistance, good moldability, poor tensile strength, low mechanical properties, poor temperature resistance, and also can be produce transparent or different colors. Some of these properties are shown due to the way the polymers band together, and this can be happen through uh, being a linear or branch cross-linked or network like type of the bond. So uh, actually my hypothesis for this experiment is that I hypothesize that by adding cornstarch to sand, I will produce a substance that, while fluid, is also hard, and it's suggesting that polymerizations has occurred. So my hypothesis is this, and in this experiment, now this experiment, my main objective of this experiment to show some of the unique characteristics of polymers through the creation of kinetic sand. um, I will describe my experiment in my another next video. Thank you. Okay, let's begin the experiment. There are two methods. One is you can made in home method by applying the cornstarch, water, and this washer, and this is sand. and another method is slime method, but I will focus this home method. Okay, now I'm going to add this sand. I brought the sand from the near the beach or near the my river. Okay, I put some sand here, then sand, and then I mix cornstarch. This is the cornstarch. I'll put this cornstarch here, 3 spoons of cornstarch. Yes, cornstarch. If I need, then I will again try to take from here, and I will mix it properly. And yeah, before that I will put water and a little amount of the water and some few quantity of this water in here. Yeah. Oh, then I'll mix it. Yeah, it's mixing well. Then I'll mix it properly. Oh, properly. I need some color. I'll put one food color to see a nice color. It's not necessary, but it will be good. Okay, I'm mixing these nicely. Yeah, it's look nice. Yes, and yes, mixing this. Yes. And we know that by adding the cornstarch and water, when cornstarch is mixed with water, it forms a colloidal suspension, not a polymerization. So the cornstarch particle disperse throughout the water, creating a mixture that can behave a non-Newtonian fluid. This means its viscosity can change under the stress or vibrations, becoming more fluid when agitated and more solid when at rest. And afterward, we're going to put a big soap, and adding this soap to the mixture reduces the surface tension of the water, and this allows sand and cornstarch to mix more uniformly. And soap molecules have a hydrophobic like water repelling and hydrophilic water attracting properties, so helping them to interact with both the water and the oily components of the cornstarch. And this sand does not chemically react with other components. Instead, it provides the granular texture. The role of the sand is more physical than chemical, and adding bulk and helping the mixture of hold its shape due to the mechanical interlocking of the particles. So this is mixed well. Now I'm going to pour this water here with my teaspoon. Yeah, I'm adding slowly and mixing it properly. Adding slowly and mixing. Wow, slowly. Yeah, and should not add more. And cornstarch act as a binder and thickener, helping sand particles stick together when pressed. And the water act as a medium, medium to help distribute the cornstarch and soap evenly among the sand particles. And Dick's soap improves the texture and prevents the sand from being too sticky and making it more pleasant to handle. Oh, we can. It's nice. So, just imagine. Wow. Yeah. Yes. Yes. Uh, but it is not that much hard what I have described before. Yes. Yeah, we can make, yeah. It is not, it is not that much hard. So I think I need to add more cornstarch here. Hmm. Mhm. Little defects. It's not hard. A little more. Instance. Yeah. So, however, despite this addition, I could not get the sand to create a consistency to be considered kinetic sand. Therefore, my hypothesis, I think, was not proven. I do not create a polymeric substance that are fluid and hard. It is not that much hard, you know. So my hypothesis is doesn't work here. So because here the polymerization is doesn't occur. Okay. Um, Thank you, and I will discuss more thing about this in the discussion chapter. Thank you. Yeah, as finally I came for the discussion. In discussion, the kinetic sand is an addition, a polymer that often appear as though it is wet, but never dies out and has a fluid-like behavior, but is also hard when squeezed. And commercially, kinetic sand is created by having a mixture of 98% of sand and 2% of dimethicone, which is also known as polydimethyl siloxane, which we can see in the picture in slide. In the kinetic sand, the polydimethyl siloxane coat the sand particles, and these and it has a flexible viscous nature of polydimethyl siloxanes, and it allows the sand particles to stick together when pressed, but slide past each other easily when the pressure is released, allowing the sand to flow. Unlike water in wet sand, polydimethyl silicon does not evaporate or react with other components, ensuring the kinetic sand remains moldable and doesn't dry out. And this in this specific experiment, the main aim to replicate this process by using cornstarch and water instead of dimethicone. Cornstarch is a polysaccharide or a polymer made up of sugar chain, and how this work is the cornstarch coats all of the sand molecules and begin to perform polymers, connecting the cornstarch sand molecule complex together in long chain. And then the water comes and suspend the cornstarch molecules, creating a colloid solution. And this colloid solution is a mixture in which one substance cons um, consisting of microscopically dispersed insoluble particle is suspended throughout another substance, and then is what gives the sand its kinetic characteristics. The dig soap is added to prevent any bacteria or mold from growing in the sand. This experiment is a good example for how polymers have different physical characteristics that can be useful in real world application, and emphasize how many things around us are made from polymers, including plastic bag, non-stick coating on pans, rubber, and more and more. um, Thank you. Thank you.